This video demonstrates the key differences between an autonomous UVC robot and a stationary UVC tower. We look at a side-by-side comparison of the same patient room. When disinfecting with UV light, there are two fundamental laws of physics we must follow. First, UVC light is line of sight. In order to disinfect a surface, the light must physically reach it. If something is shadowed or blocked, like the far side of this bed, it will not be disinfected. Second, distance dramatically affects disinfection efficacy. This is explained by the inverse square law, which tells us that the intensity of light drops exponentially with distance. Now, notice on the left how quickly the autonomous disinfection completed the entire room in a heat map in just 2 minutes and 15 seconds. Meanwhile, the stationary device on the right continues to run despite being placed at an optimal position to disinfect both the bathroom and the patient room. Notice the difference in the heat map shapes, which have a missing section representing the large shadowed regions behind the bed in the stationary example. This area remains untreated because the UV light cannot bend around obstacles. This isn't a flaw in the design of a stationary disinfection tower, it is simply just physics. The extra time we're now seeing from the stationary device, it's demonstrating how the effectiveness of UV light quickly drops with distance. Finally, our stationary disinfection is now complete, taking a total of 6 minutes and 3 seconds. Now let's compare the two. The autonomous robot was 3 times faster, it made a complete heat map, and as a result, there were no missed surfaces from shadows. Now it should be noted that as rooms get larger, such as operating rooms, these effects are only amplified and often result in disinfection times that can take 10 times longer. Autonomous UVC disinfection is not just a convenience, it's a necessity for modern infection prevention and to ensure rapid room disinfection.